Good evening, class. I hope everybody is doing fine. We're dealing with the conics. So we started looking at it as of last session. So we have already looked at circles, and that's actually part of the conics. I want you to know that. Then parabolas, okay, ellipses, and hyperbolas. So this is the synopsis of dealing with complex plane and the Moore's theorem. I hope everybody remembers that. Fairly straightforward. Okay. A plus bi. That's the same old complex number we have dealt with. Now a plus bi or x plus yi makes no difference. And now we can write it in polar format or cis theta, and it gives rise to interesting theorems such as the Moore's theorem. Vectors, and in short, vectors addition basically follows vectors operation of numbers in that sense, meaning they have the same associative property, commutative property, and so forth. Vector magnitude, okay, it basically follows Pythagorean theorem. If you have the components A and B. When we write AI plus BJ, okay, I is along the X direction and J is along the Y direction, okay? So that's what we mean by AI plus BJ, or we simply use brackets A comma B. And the unit vector refers to the fact that the magnitude is equal to 1. Okay. And with that being the case, if we were interested in finding the unit vector in the direction of a specific vector, all we had to do, divide the vector by its magnitude. So that's important to remember, and find the vector from its direction. It uses the magnitude of the vector times cosine alpha I plus sine alpha j. This was the synopsis of the chapter dealing with the conics. First, as you can see on the right side, okay, what's happened? I think, did I move something? Okay. So first we dealt with, I refresh your memory about the circles. There are two types of formulas. One centered at 0, 0, which gives us x squared plus y squared equals r squared. And another one which is centered at h and k. So x minus h quantity squared plus y minus k quantity squared equals r squared. With that goes the distance formula and the midpoint formula. We've seen them all along. They are extremely important, and you're going to revisit them again and again and again. So you're going to be very comfortable with that. Now, there are 3 more conics, okay? Parabolas, ellipses, hyperbolas. And in this section, we dealt with the parabolas. I gave you the synopsis of the rest of them in this section, meaning the very first one. And so let's continue on that thought, dealing with parabolas and taking it from there. All right, first of all, how do we come up with conic sections, and why are they important? They are important because they really have a lot of applications, especially in physics and optics, okay? Then if you happen to have 2 cones putting together from the vertex, okay? You're looking at the right circular cone. It has what we call an axis, or axis of symmetry. Now, if you use a plane to cut this in various formats, if you cut this parallel to the axis of symmetry, it gives rise to a hyperbola. If you cut it perpendicular to the axis, it gives you a circle. If you cut it with an angle on one side, okay, it gives you an elliptical shape. If you cut it in one side and it goes through the base, one of the bases, it gives you a parabola. First, I reminded you about the basic formula that we are supposed to remember, hopefully from algebra. And in that case, we have two cases. Either it opens up and down or sideways. All you need to remember is very simple. If it's quadratic with respect to x, it opens up or down. If it's quadratic with respect to y, it opens right or left. And it depends on the value of a. If a is positive, up or right. If it's negative, down or left. So basically, we repeat the same thing here. And I added this definition of a, a lattice spectrum, which has the distance of 4p. Now, what is p? P is the focal distance, the distance from the vertex to the focus. The distance from the vertex to the focus. Okay, and it gives rise to the definition of a parabola as set of points, pick any point, and they have a fixed distance from two things. One of them is the directrix, and one of them is a focus. Now, remember how this thing is going to play out. Focus and directrix are on opposite sides of the vertex. Okay, opposite side of the vertex. Okay, so and so you see various formulas. Okay, y squared equals 4ax, and I mentioned this a is really not the same a as the p, and that's why I like to use p. But I have seen y squared equals 4ax used in many texts, and I want to make sure everybody understands this a is not the same a that we discussed, okay, as a leading term, if you will, of the quadratic format in algebra. So this is really p. That's why I rather use 4px instead of 4ax, all right? And the relationship between this a that we have learned, this good old a, okay, when we write, for example, y equals ax squared plus bx plus c. The relationship between this a and the focal distance is that the focal distance is 1 over 4a, or a is 1 over 4p. Okay. Okay. So first, I reminded you about what we did in algebra, meaning how did we graph this in algebra? Well, it's very basic. You come up with the vertex, you come up with the intercepts, you realize whether it opens up or down, and practically you have the graph. You're done. That's all there is to it. Okay. Because it is quadratic with respect to x, you know it opens up or down. And because a is equal to 1, which is positive, it opens up. Okay, so I want to just remind you of what we did before. In this case, quadratic with respect to y, so it opens to the right or left. Which one is that? Because it's x equals negative y squared. So the leading term has a leading coefficient which is negative, it opens to the left. Now, how do you graph this? In the same manner, come up with the vertex, come up with the intercepts. If need be a couple more points, you have the graph, you're done. That's simple, okay? And I want you to stick with that. You can stick with algebra, and if need be, you change it accordingly. Remember, the relationship between P and A is very simple. P, the focal distance, the distance from the vertex to The focus is P equal 1 over 4A. In this example would be 1 over 4 times negative 1, which is 1 over negative 4. But the distance, the focal distance, we take the absolute value of that. I want you to know that, by the way. Okay. So maybe we should write this as the absolute value of 1 over 4A when we, what really matters is this. Okay. If you have the vertex, remember, then you know where the focus goes, where the directrix goes. For example, in this case, the focus is in essence, you can think of as inside the parabola. So the focus is on the left side, okay, of the vertex. And the directrix is on the right side of that. All right, so I hope everybody is comfortable with that. So just for the sake of argument, if this question is given, let me just add something to it. Maybe, you know, even this one, if I want to add something to it, okay. Let me add this. You're done with this. Everything is fine. Now, if they're asking for the location of a, you know, focus, okay. And the equation of a directrix. Actually, let me give everybody a minute. Can you tell me, okay, so we did this already last time, and I suggest use the good old algebra, you're fine. But what if we added, okay, give me the coordinates of the vertex, okay? I'm sorry, focus. Give me the equation of a directrix. So I want to give everybody a moment. Can you think about that and come up with the answer? How do you come up with the location of a vertex? What is the location of a vertex? What is the equation of a directrix? Can anybody share with us the answer? The vertex is located at 3, negative 1, right? Now, where is the directrix? The directrix looks like this. I don't know the equation. I'm going to come up with that. And the focus, this is not two-scale class. The focus is somewhere here. Do you see that? Is everybody following that? Now, let me quickly see how we can come up with that. Okay, this looks horrible. Let me just, the line is not. So this is the line, if you will. Okay, now remember this distance. This distance is P and this distance is P. So what is P? Well, P is 1 over 4A. So 1 over 4 times 1, so 1 over 4. So all you have to do, if this is the vertex, the focus is located at the same x coordinate. Now the same y coordinate, add 1/4. Okay, which is F is located at 3 and negative 3/4. Again, that's why I said this is not two scale. I'm just throwing something there to let you know. I know it's really on which side. Are you with me? Okay. Now, what about the directrix? Directrix has the equation y equals. Okay, Look at the y coordinate of your vertex. The y coordinate of the vertex is -1, right? Now, it's on the other side, so you got to subtract the p. Okay, you got to subtract the p, and it gives you -5/4. That's why, if I'm giving the situation like this, I sort of have a rough sketch before I can answer. That's the fastest way to come up with the answer. I hope everybody's following that. I hope everybody's okay with that. When we did this, we finished the job and we came up with the graph. Now, can you do the same thing here? From the vertex, give me the location of a focus and give me the equation for the directrix. Can you figure this out? Here's the directrix. Here's the location of a focus. None of them is to scale, but I hope everybody understands. You know, instead of memorizing, understand when you have a graph, you know which way is the focus, which way is the directrix. So P is 1/4A. This is one way to write it, 1/-4, but you really want a distance of 1/4. So you really want to go with the absolute value, which is 1/4. Now, the vertex is located at 4, 1. So 4, 1. It is to the left of that vertex, okay? It is to the left of that. So 4 minus 1/4. Directrix is to the right. So x equals 4 plus 1/4. And everybody knows the answer. This is, 17/4. This is 15/4. So I hope you see that knowing which side it belongs to, you can handle it, okay? I think we have spent enough time on that, so I'm going to move on. Okay, sounds good to everybody. Any questions, class? If you look at the previous page, we did this in the same manner. Now, to come up with this, I said, what do we do? I would start with the graph. So, again, we didn't do it right now. We had the graph at the end, but remember what I did. I started with a rough sketch. Okay, doesn't have to be to scale. You make it to scale later on, okay? But when you have a rough sketch, it will help you come up with everything else. Sounds good? Okay, we're going to move on, and I'm going to stop the video, so when we record it, it becomes nice and easy to do so. So let's okay. All right, we are going to go to the next example. Everybody is okay with that, I hope. All right. So let's do this. Analyzing the equation of a parabola. Again, even if you don't put that in standard form, you should recognize It's a parabola that opens either up or down because it is quadratic with respect to x. I hope you see that. Okay. Now, basically, we are going to solve it and we're going to put it in standard form. Okay. So I'm going to first notice that you have x squared. So you want to put it in standard form using x squared. So if you want to go with a times x minus h quantity squared plus k, that's what you get. Now, you can see probably that, okay, x squared plus 4x equals 4y, okay. So let me just go through the process of showing you how you come up with that. This is the first step. Then I hope you see, in order to complete this square, I need, what number do I need to complete the square on the right side? My apologies, on the left side. Can anybody tell me what number we need?
4.
4. So I'm going to add 4 and I'm going to subtract. Okay, you have two choices, class. You can add 4 to both sides, or you can add and subtract on the same side. It really doesn't matter. So now, this is x plus 2 squared minus 4 equals 4y. I hope everybody can see what we have here. Now, if you divide both sides by 4, divide by 4, you have the answer. Okay. So y equals 1/4 x plus 2 quantity squared minus 1. Now, this is a simple case. We have the vertex located at -2, 1. We can find everything else. First of all, this opens up because a is positive, 1/4, okay? So you have an idea, just for the sake of argument, okay? Again, I'm going to erase that, but so the vertex, it's somewhere here, and this is not to scale, but just right then and there, it opens up like that. So you have a shape, roughly, class. Of course, this is not good enough. You have to find the intercepts if you want to graph it and everything, as everybody can find the intercept. X is 0. Find y. Okay, y is 0. Find x, and so it's really not a big deal. Okay. So you can find them, all right? Now, what I want to do is just go through the rest of that, knowing the relationship between P and A. So we're going to write the vertex is -2, -1. Okay. And so if that is the case, I had the graph for you. Then we know the focus using the vertex. The focus is located, okay, with the same x coordinate as the vertex, and it goes up by this much, okay, if you will, okay. So you add 1 to it. But the directrix comes down by that much, okay. So I hope everybody can go from here to here. So one more time. The vertex, okay. Again, let me just quickly graph this. So graph looks, this is not to scale. In fact, you know, it goes through 0, 0, because if you plug in x is 0, y is 0. Let's just make it a tad better. You know, so you have a graph. This is not to scale. Because this is the vertex, then again, by no means I want to go to scale. I want to make sure that the focus is somewhere up here, and the directrix is this one. None of them is to scale. You got to come up with the equation of a directrix. You got to come up with the location of a focus. But you should have an idea where it's located with respect to the location of a vertex. Okay, and that's really my point. All right, so it ends up being at negative 2, 0. Okay, so class. So the focus as at negative 2, 0. This is y being negative 2. And so what you're looking at here, okay, this is lattice rectum. Remember, goes through the focus, and it is parallel to the directrix. So you can find the location, okay. Oh, the order is really, okay, let me just, I actually meant, okay, I don't want to, okay, so you have the graph. I'm going to show you the, graph before that, but, so y equals 0. You can find the x coordinates are 0 and negative 4 for lattice rectum. I want you to see that, okay? Or you can do it at the end. You can look at the graph and figure it out at the end. That may not be a bad idea. But let me explain this one. Everybody look at this formula. I hope you see that this is really, if I were to change it, if I were to get rid of 4a, I can put it on the other side, okay, becomes 1 over 4a. Okay, let me just, it's hard to do it like this. So 1 over 4a, and this one you can cross out. Now move the k. Let me just now write it here. So 1 over 4a class, 1 over 4a times x minus h quantity squared plus k equals y. Okay, I hope you see that this is the same equation, except this a that you see here is really the p. That's why I can't emphasize this enough, class. I don't like to use the a for this section. You see it in some text. I like to use p, so it is important. Let me erase that and explain. If I were to write this, I wouldn't use 4a, I would use 4p, because I don't want this a to be mixed up with the a that we used in algebra, okay? Here, this a, okay? This a is different, class. I can't emphasize this enough. We don't want to mix them up. So that a is different than the a that you see at the bottom. But I'm giving you both the equations because I want you to see, compare, and understand the difference between the two. What is the difference? This is the way normally they represent it in higher courses. But remember, when they represented, that is referring to P, the focal distance. So we finished the job, finding this x squared plus 4x equals 4y. We've added that, okay, and that's the formula. Now we've already done that. We can go directly from here, if you will, to that, okay? That's the same thing, class. I hope you see what happens. And so that's the graph. Now, erase that. And so we can come up with the latus rectum. I think the best course of action is just look at the graph, okay? By the way, those are very easy points to find, okay? X is 0, find y is 0, find x. So you set y equal to 0 and you solve it. If you set y equal to 0, it gives you those intercepts. And latus rectum has, remember, the same y coordinate as the focus in this case, the same y coordinate as the focus. All right, I think we have overkilled it, so we're ready to move on, I hope. Okay. So let's go to the next example, class. Okay. If I'm doing this, if you remember, I said, I'm going to graph this because I want to have a rough idea how it looks like, and then from there, I'm going to move on. So can I put it somewhere so I don't have to erase it? Let's graph it here. Okay, remember, we don't want to precise. We just want to see, have an idea whether the graph opens up, down, left, right. That's really the idea that we are interested in. So we want to find the equation of a parabola. The vertex is located at negative 2, 3, somewhere here. Okay, 2 to the left. Okay, now negative 2, 3, I mean, this is, my apologies. 2 to the left and 3 up. So let's just do it this way. So this is the vertex located at negative 2, 3. What about the focus? The focus is located at 0, 3. Okay, so because focus is on the right, if I were to graph it, and this is, again, this is not to scale, and that's not what we are interested in. We just want to know how it's supposed to look like. It is supposed to go this way. Everybody can see that it's supposed to open to the right just because of this and this, because of the vertex and the focus. So I have an idea how the graph looks like. Now the rest, so it opens to the right. So I know that, okay? Now, what is my focal distance? Let me see if I can use a different color to show you. So now this is the distance we call P, okay, class? And this is the line, we call it directrix. And x equals something. Let's figure those just for the sake of argument, so you see how that works. So P, the focal distance, is the distance between the two. So it's distance between these two. Okay. So obviously the distance therefore would be 2. P is 2. It opens to the right, the P is 2. Okay, so if this distance is 2, so is this distance. So it's all the way to the left by 4. So the directrix is having equation x equals -4. So I hope you see that's very straightforward, okay? And because it opens sideways, we are going to use x equals a times y minus k quantity squared plus h. Why? Because it opens to the right, okay? So what is a? So we say, let me just fix this, doesn't look good. P is 2, right? So what is a? 1 over 4p, okay? So that means 1 over 4 times 2, 1 over 8. Practically, you're done. I hope you see that we have a rough sketch. We found we found the location of the vertex, the focus. We have the equation of a directrix. We can find the value of P. We can find the value of A. We are almost done. So using that, x is equal to 1 over 8, y minus 3, quantity squared minus. So I hope you see that this will result in this equation. Now, how do we write it for the sake of this section? Remember, we just move the 1 over 8 to the other side and minus 2. So let me just use different color. So this -2 moves, becomes +2, and this 1 over 8 moves, becomes times. Okay. Okay. Let's discuss the lattice rectum also. Okay. Lattice rectum, of course. Okay. The focus is located at 0, 3. Okay. We want to see what x equals. Okay. When x equals 0, what is the y? Remember, it is on the line segment, if you will, that connects the 2 points, and it goes through the focus. Because the x coordinate of the focus is 0, the x coordinate of the lattice rectum is also 0. That's the idea behind that. In other words, we are saying this is 0, comma, we got to figure it out. This is 0, comma, we got to figure it out. That's the idea behind that. Okay. And so how do you find it? You just put it into the equation you just found. Okay. You can put it into the equation and solve it. Okay. So those are the locations. Okay. Let me just actually erase this so you have a better graph. You can see the better graph. Okay, so that's a graph. So take a look. We had an idea how it looked like. It wasn't to scale, but that's fine. Now we have a better idea how it looks like. We had the correct location for the focus, for the vertex. It opened to the right, and we also had the directrix. By the way, the axis of symmetry is very easy to see, by the way. It goes through the focus. Okay, y equals 3. The axis of symmetry is always perpendicular to the directrix. And so we can rewrite this in this format. And remember, this A is really the P that we have. But you don't have to worry about that. As I mentioned, you move things around, okay, and you'll be fine, okay? So you move the -2. And if you want to go from here to here is easy, or just the fact that you know the vertex, you can graph it. And this gives you the synopsis of everything was just done and discussed. This is being basically repeated, okay, class. And so to find the points that define the lattice rectangle, let x be 0, so that y minus 3 squared equals 16, y minus 3 becomes plus minus 4, y is negative 1, so on and so forth, okay? So you can find it through the process that was mentioned. It's a very simple process, class, okay? All right. I hope everybody's okay with this, so we can move on. Assuming we are okay.
Yeah, it's okay.
All right, excellent. All right, there are a lot of applications, as I mentioned, when it comes to conics, okay? One of the important applications is in optics. Just look at this light and where it's located. I can't emphasize this enough. This is used even for, you know, cars, okay? The location of a light, okay, is at focus. So the characteristics of a shape involving parabola is such that when it hits the wall, it goes parallel to the axis of symmetry. I hope you see why this is used, okay, for like headlights in the car, okay? Okay, so where do they locate the light ball? They put it right on the focus. The characteristic is such that as it hits the ball, it goes parallel to the axis of symmetry. So that's one example of that. Anyway, so here's an example of this. Okay. Could somebody be kind enough to read this for us, please?
A satellite dish is shaped like a paraboloid of revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point where the receiver is located. If the dish is 3 feet across at its opening and 8 feet deep at its center, at what position should the receiver be placed?
Thank you so much. Thanks, Mercedes. And so basically what we do when we have a case like this, we just assume that it's, you know, along, it's a simple case, which is along the X or Y axis. It doesn't matter which one you use, but let's draw this in this fashion, okay? To make life easier, you use a rectangular coordinate system, okay? And you are saying, okay, this point is the same as this point. That's the idea behind that, okay? And so you take it from there, okay? And we want to see what's going to happen if you are looking at this case where this is 3 feet. Look at this one. This is 3 feet, and this is 8 feet. Then this will correspond to this point and this point. I hope everybody can see why this is the case. Okay, you just turn it around. Okay, you just turn it around such that it is the vertex, if you will. The vertex, if you will, is located at 0, 0. Why do you do that? Just to make your life easy for the calculation. That's all. Okay, so we turn it around, we put it there, we want to calculate. Okay. Now, the bottom line is, in order for this to work, you have to find the focus. That's the idea behind that, class, okay? And so remember the formula, okay? First of all, this opens up the way we have set it up. And so it uses one of these formulas. Okay. Where is the vertex located at class? 0, 0, according to what we did. Then I hope you see the equation becomes what? Y equals ax squared. Everybody can see why this is the case? Because the vertex is located at 0, 0. So what can we do? All we have to do, pick up one of those pairs, either negative 4 comma 3 or positive 4 comma 3. Put it into the equation and find A. Before we do that, I hope everybody is okay. So quick recap. First, it doesn't matter how you set it up. It makes life easier if we go with the rectangular coordinate system and we assume the vertex is at 0, 0 and it opens up. You can assume it's at 0, 0 and it opens to the right and do it that way. It makes no difference. You get to the same answer, okay? Because we are interested really in finding the focal distance. That's what we are interested in. So with that being the case, if you plug in 4, 3, okay, that means you replace the x with 4 and y with 3, and you can find the missing a. So a is 3 over 4 squared, which is 16. So the equation is y equals 3 over 16 x squared. But what about the p? P is 1 over 4a. P is 1 over 4a. We find that 1 over 4a, please understand this means 1 over 4 times 3 over 16. That's what it means, okay? And so I hope you see this becomes 4/3. And we use the same units, feet, okay? So 4/3 of a feet. So that means from the base, this must be 4/3. By the way, A is not a good choice. Let's say 0 Y because we don't want to mix up this A with the other ones. And so the receiver should be located 1 foot, 4/3 of a feet, which means 1 and 1/3, which means 1 foot 4 inches. I hope everybody remembers that. Okay, 1 foot 4 inches from the base, okay, along its axis of symmetry. And the reason we mention it this way, because class, it doesn't matter how you tilt it, okay? You just want to know the distance that you have to, you want to find the focus. That's the idea, which is some distance from the, vertex, if you will, okay, or the base. Any questions? Is everybody okay with this? All right, so we want to go to the next topic, dealing with an ellipse. And in fact, since it's a new topic, I'm going to stop for a second. I'm going to pause the recording. Okay. All right. Just like any other conic, an ellipse has a specific definition. The definition is that an ellipse is a set of points in a plane, set of points. Okay, points. Okay, so such that the sum of distances from two fixed points is constant. Okay, the two fixed points are called foci, focus 1, focus 2. Now, which one is focus 1, which one is focus 2 makes no difference. Okay, and the sum is equal to 2a. I want you to know that. This fixed, okay, it's from 2, it's constant. This constant is 2a, 2 times a. Okay, a along the, if you will, if it's if the center is at the origin, a comma 0 and negative a comma 0, that are x-intercepts. They represent the vertices and they're on the major axis. The major axis meaning the one on the side that is elongated. Okay, so if you pick any points and you connect it to F1 and F2, they must add up to the same number, and that number is fixed and it is 2a. So I hope you remember this stuff. So x-intercept is at a0, negative a0. If it's elongated along the x-axis, those are called the vertices. The y-intercept would be at 0, b, and 0, negative b. This is in the case of a standard form where x squared plus y squared, x squared over a squared plus y squared over b squared equals 1. So for this case, use a different color class. So x squared over a squared plus y squared over b squared. This is standard form centered at 0, 0. Okay. And for example, PF1, okay, in this case, this point is P, okay. So PF1 plus PF2 is fixed, and that happened to be 2A, okay. And it's very important to see why. If you want, all you have to do is just pick up this, call it A, pick up this point, call it A prime, and AF1, so he proved, let me just quickly show you. I hope you see why this is the case. AF1 plus AF2 is the constant, right? K, constant, okay? And I hope that this 2, AF1 plus AF2, we can replace the AF2 by A prime F1 by symmetry. And this is A prime, and that is 2A. So that's a proof in case. Okay. Now, the other thing that we want to make a point of, if this point is B and this point is B prime, okay, that's what I have for you here. This is another proof for you. BF1 and BF2, they add to this constant because it's on the ellipse position, so it's A. And then BF1 is identical to BF2 equals A. Why is that? By symmetry. Okay, by symmetry. Remember, this distance is the C, and so is this distance. Okay, so these two small triangles are identical, and so by Pythagorean theorem, okay, if we look at one of those, let me again use a different color. If you look at, for example, this side, we can use Pythagorean theorem for this one. Okay, and so b squared plus c squared equals a squared. Now, what I want you to remember is that basically you use the Pythagorean theorem What we used here, A is along the x-axis, the elongated version. If it's not, if by any chance B is larger, then it's A squared plus C squared, which is B squared, okay? If, just write that. If A is smaller than B, that means the major axis is along the y-axis, then this formula changes to what? Okay, A squared plus C squared equals B squared. I hope you're not going to be, hooked up with just the formulas. Understand Pythagorean theorem. There are two legs and hypotenuse is the largest side. Whatever the side is the hypotenuse. In this case, we are assuming it's along the x-axis. If it's not a big deal, okay? But the relationship is such that we can easily find A, B, C as long as two of them is given. That's the idea behind that. I hope everybody's comfortable with that. All right, so here's a simple example. We want to graph this. And we want to label the intercepts. First, it's in standard form. Therefore, it is centered at 0, 0, okay, with A being 4, square root of 16, and B being 2. So I hope everybody can see that, okay. And so we have A, we have B, we have the center, okay. So we should be able to recognize this is the case, x-intercepts, and B equals to. This is just by writing it in standard form and noticing what's A, what's B. Now, in order for you to graph an ellipse, I want you to think of it very simple, okay? All I need, if it's centered at 0, 0, I need the vertices, okay? And then I have my y-intercepts located at 0, 2, and 0, negative 2. And I have the graph. I hope everybody can see how simple this thing is. It is extremely easy class. You should have no problem graphing it. 4 points, connect them. Just make sure that they are connected with a curve, not a line segment. Okay. The next thing I want to add is this. Find the area of an ellipse, okay? Now, it is important for you to know that circle is a special case of an ellipse, okay? An ellipse has two foci, F1 and F2, okay, class? If they get closer and closer, I hope you can see that when the foci get closer and closer together, it is less elongated and it gets closer and closer to a circle, okay? When C equal to 0, you end up with a circle. Okay, so let's say this is not to scale. This is F1, this is F2, and this distance is 2, okay? Remember, the distance is 2C between the two foci. So when F1 and F2 get closer and closer, I hope you see that, you can visualize that, then it becomes closer and closer to a circle. So a circle is a special case of an ellipse where F1 and F2, two foci become one focus and we call it a center, okay? That's the idea behind that. And as you recall, for a circle, the area was pi r squared. So what happens if F1 and F2 get closer and closer, we no longer say we have A and B, but rather A becomes identical. If C is 0, then A becomes B and we call it R. So let me make sure everybody understands what I'm saying one more time. If the focal distance becomes 0, then A is equal to B, and we no longer call him A or B, we call him R. And we know the formula is A equals pi R squared. And with that, with the inspection, we should notice that A equals pi AB, therefore. Does that make sense, everybody? So plug in A and B, and that's the area of an ellipse. We look at the proof of this in calculus, okay? But I hope it's very straightforward. Again, circle is a special case of an ellipse, as square is a special case of a rectangle, where the width and the length become identical. We call them S or side. Okay. We want to find an equation of an ellipse with center at the, okay, everybody, I hope everybody was done here, class. So we finished the previous example and we want to move on, okay? We want to find an equation of the ellipse that has a center at 3, 0, at the origin, my apologies, at the origin, 0, 0, okay? And focus is at 3, 0, and a vertex at negative 4, 0. Just, you know, again, just to give you an idea, okay? It means here's the center, okay? And the, one of the four, okay, 1, 2, 3, 4, let's say. So this is, let's say, F2, okay? And then a vertex, 1, 2, 3, 4, 5. So the vertex is located at one of them, negative 4, 0. So just because of that, you should know it'll look something like this again, just to give you an idea, okay? Now, even you may not know, but that's the idea, because this is the one of the vertices elongated along the x-axis. Now you just make it look good. This is just to give you an idea, okay? Of course, this is minus 4, 0. This must be 4, 0. Okay, I want you to know that. So it really goes through that. But I was saying, you know, even if you don't know where that location is. In any event, so with that being the case, that means A equals 4 and C equals 3. Okay, class? So A equals 4, right? And C equals 3. I hope everybody understands why. And so everybody remembers that B squared plus C squared is A squared. A is the largest one in this case, okay? And so you can find the value of B. So B squared is 7, and B is square root of 7, okay? By the way, we wanted this equation, but understand what this means. B is square root of 7, okay? B is square root of 7. I hope everybody understands how we arrived at the answer here, okay? Very straightforward, okay? And this is obviously a better graph. Let me just erase the horrible graph I had, just, okay. All right. So this is it. We are ready for the next example. Okay. We want to look at this example. I hope you realize this is a conic section, and more specifically, it is an ellipse because the coefficients of x squared and y squared have the same sign. How do you put that into standard form? You divide both sides by number 9. Why? Because you want the right side to become 1. So you want to divide both sides by number 9. So when you do that, you end up with this. Okay, does that make sense? Everybody okay with that? So what is A? What is B class? You should have no problem recognizing that this is x squared over 1. Therefore, A squared is 1. B squared is 9. And so we have A equals 1, B equals 3. So x-intercepts are at plus minus 1, 0, and y-intercepts are at 0, plus minus 3. And obviously, it's elongated along the y-axis this time. We should recognize that. So all you have to do, plot them, and there you have it. Okay. Now, as far as focus is concerned, focus is, there are 2 of them. Both foci are along the y-axis. So you can find that, okay? Now, this is what I mean here, that in this case, if we were to write the formula, we would write a squared plus c squared equals b squared. Why is that? Because b is the longest number, okay? Because it's elongated along the y-axis. And so this is a squared is 1 squared plus c squared equals 9, and c squared is 8, and c is plus minus square root of 8, or 2 square root of 2. Okay, c is plus minus square root of 8, or plus minus 2 square root of 2. And so if we were to graph, it will look something like this. Now pay attention to the fact that it is elongated along the y-axis class. It is elongated along the y-axis. Okay. So the foci are on the y-axis. Okay. Any questions, class? Okay. Here's the next one. I'm going to give everybody a minute. I'm going to pause the recording. You should be able to handle it, understand. Of course, you need to use completing this. Remember what happens is that you want to put this in standard form, okay? So with that being the case, We want all the x's together, all the y's together, and the constant goes to the other side. We are going to complete this square for this guy and this guy. Okay. So the first one, in order to complete this square, you need to take the 4 out. The second one, you don't have to take anything out. So I hope it's very straightforward. So now you need to add something here. So you need to add b over 2 quantity squared. So you need to add 1. So you add 1 to both sides. For the second one, you need to add 4. So I hope it's very straightforward. This is completing the square. We have overkilled it. You should have no problem handling that. Okay. And so now we have the following. Now we divide both sides by 4y because we want to make it 1 on the right side. So when we do that, this is what we get. And I hope you see from here right away you recognize A is 1, B is 2. Okay. And because B is longer, it is elongated in parallel to the y-axis, along the y-axis. And so therefore it is A squared plus C squared equals B squared, and you can find that easily. Okay, so C is square root of 3. Okay, focal distance. That means distance from the center. Now, where is the center located at? Okay, now when we look at this standard form, the center is located at 1 minus 2. Okay. What about the other 4 points? Okay. The way I want you to understand that your graph is very simple. Write the center, class. Write the center. 1, comma, negative 2. Then go by A units to the right, A units to the left. That means add and subtract A from the x coordinate. The x coordinate, okay? And then you go up by B units and you go down by B units. And those are the other 2 points. They happen to be the vertices because elongated along the y-axis. But I hope everybody understands how we arrive at those points. Okay, so one more time. Center, wherever the center is, go to the right and left by A units, go up and down by B units. Okay. As far as the C is concerned, okay, from the center, okay, for the foci, F1 and F2, from the center, go up by C and go down by C. And those are the coordinates of the foci. So center is at 1, negative 2. Okay. We are going to add B. So if you add B, you get 1, 0. We are going to subtract B. You're going to get negative 1, negative 4. Same thing happens with the foci. up and down by square root of 3. By the way, square root of 3 is about 1.7. And if you graph it, this is the graph with details class. Okay, so I want to make sure everybody understands how we do the graphing here. Everybody can hear me, right, class?
Yes.
Okay, because I thought, you know, my headphone got disconnected. All right, you come up with the center after you put it in standard form. You come up with ABC, okay? Now from the center, A units to the right and left, those are 2 points. B units up and down, those are 2 more points, and that's your graph. Location of foci, from the center go up and down by C units, whatever the number may be, okay? So that's the idea of an ellipse. We're gonna go to the last part of conics. Hyperbolas. Now, hyperbola has a similar definition to an ellipse. The difference is that hyperbola is a set of points that the differences of the distances are fixed, okay? Now, from 2 points, the 2 points have the same name, foci, focus 1 and 2, okay? And this distance is fixed at 2a again, okay? Remember, if you pick any point, for example, this one, if you call it P, okay? So PF1, that seems to be larger, right? So PF1 minus PF2 is fixed, okay? And this is located at A0. This is located at negative A0. And those are the vertices. If it opens up and down, like the third graph, this one, the vertices are along the y-axis. So we need the center and vertices. The vertices either go along the x or y-axis. It's a very simple case. Okay, now, what we have here, we also have what's called a transverse axis. Okay, if it's along the x-axis, that is the transverse axis. Okay, if it's along the y-axis, that's the same thing. Now, I want you to notice this one. Okay, a squared plus b squared equals c squared. Now, c happens to be inside somewhere here. For example, here is, okay, f1. We already have it here, so f1 and f2. And c is always larger than a and b. So it's always the same formula, a squared plus b squared equals c squared in the case of a hyperbola. Okay, sounds good. So we come up with the vertices, okay? We come up with the center, and we can easily graph this. Now, again, we are repeating the same formulas. The only thing I want to add, again, a couple of things. One of them is about the asymptotes. Now, again, in some text, what they do, they put the A on there, the one which has a positive coefficient. I hope you see that. In this case, x squared has a positive coefficient. In this case, y squared has a positive coefficient. If you keep them intact, then the formula for the asymptotes do not change. If not, it has to change and you have to memorize a new one, okay? So the best course of action is to keep A under X and B under Y always, and the equation of asymptotes remain unchanged, okay? So with that being the case, the first one, I'm going to call it number 1, okay? Hyperbola centered at the origin. Vertices are at A, 0 and negative A, 0. I'm going to call this number 2. Same center. Vertices are along the y-axis, okay? So number 1 opens sideways, number 2 opens up and down. Now, how do you graph this? You have two choices. Graph the asymptotes and go along the asymptotes. Or one easy way to graph the asymptotes, you can graph this class known as fundamental rectangle. When you connect the diagonals, those are the same as the asymptotes. This is just for the sake of helping us graph. And notice they are all dashed. Why is that? The asymptotes or the fundamental rectangle, none of them is part of the graph class. Both of them are there to help us graph, but none of them is part of the graph. I hope everybody remembers that. It's a very straightforward concept. Let's look at an example. I hope this stuff is coming back to us from algebra. All right. What we want to do, we want to graph this. And remember, first of all, because there is a negative sign in between, that means we are dealing with the hyperbola. Because we have x squared, okay, having a positive value as the coefficient is in essence is 1/9, you should know it opens sideways. And that means you have x-intercepts instead of y-intercepts. So quickly, you can see A is square root of 9 and B is square root of 16. So that shouldn't be any problem. So the vertices are located at negative 3, 0 and positive 3, 0. What about the equation of asymptotes? Plus minus b over a times x. And those are the equations. Okay, now, how do you graph these? You have two choices, class. You can graph that fundamental rectangle, okay? Just quickly just show you something here, class. And then, okay, so 1, 2, 3. So I'm going to go 3 to the right, 3 to the left, 4 up, because B is 4. 4 down. That's my fundamental rectangle, okay, class? And that's my inter. Let me use a different color. So I have 3, 0 and negative 3, 0. And the thing is, if I want to graph these two lines, class, I need a couple of pairs. And the pairs, I hope you see that. This is really y equals 4/3 x. And if I were to pick up a couple of pairs, okay? If x is 0, y is 0, okay? If x is 3, y is 4, so that means really this point. Are you with me? And this one is the other equation, y equals negative 4/3 x. And if you were to pick up those two pairs, you see, so I hope you see why we graph those diagonals. So if you want to graph this function, all you have to do this, I'm sorry, hyperbola, okay, use a different color. This is your vertex, just connect them like so. Okay, connect them like so. And you're done. Okay, what I want to show you, I want to show you something else in a moment. So here's a better graph, right? What I want to show you is the following. What if we had, let me see what color we can use here. I can use probably red color. What if, so if I change this, okay, to, take a look. If I change this to y squared over 16 minus x squared over 9 equals 1. So what happens is that I have the same asymptotes. I have the same asymptotes. However, take a look. This is one of my intercepts. This is one of my intercepts. So the graph looks like that. I hope everybody can see what I'm doing here. And I hope you realize how easy it is. As long as you have your asymptotes, you're practically done. All right, sounds good, everybody. Let's go to the next one. So I hope you understood what happened. This is really a good synopsis of all you need to know about hyperbolas. That's how easy it is here. All right, so here's the next one. Okay, so by the way, as far as the foci is concerned, you use the same formula as I mentioned, class. The formula that you use is a squared plus b squared equals c squared. A is 4, okay. So basically 9 and 16, okay, that becomes 5. Why do we have plus? Okay, did I? So a squared, it's 9 plus 16 is c squared c. Okay, so c is plus minus 5 class. The foci is plus minus 5. So the foci, this is focus 1, this is focus 1, plus minus. Okay, sounds good, everybody. All right. So plus minus 5, a squared plus b squared equals c squared. Okay. So remember that, and you can use that. All right. I think we are good to go for the next example. Okay. So plus minus square root of 7 was wrong. Okay, class? Plus minus 5. All right. We want to find the equation of a hyperbola. We have the vertex. I mean, the fact that it says at 0, 2, that means it opens up and down. Do you follow what I'm saying? And because the vertex is at 0, 2, okay, looking at this formula, it opens, so that means B is 2. I hope you see that. And because the foci, okay, so this means B is 2. This, the two of them mean C is 3. So that's just from the given info. The given info, B and C are given. So how do you find A? Remember, A squared plus B squared, which is 2 squared, which is 4, equals C squared, which is 3 squared, which is 9. Okay, so A squared plus 2 squared, which is 4, 3 squared, which is 9. So it becomes 5. So A is plus minus square root of 5 in essence. And so y squared over 4 minus x squared over 5 equals 1. That's an easy graph. I hope you realize that if you want to graph the asymptotes, just for the sake of argument, y is plus minus b over a times x. So y is plus minus b, which is 2, over a, which is square root of 5, x. And you got to graph those, and it shouldn't be a big deal. Over here, I don't have the asymptotes or a fundamental rectangle because this number square root of 5 is not a nice number, but it's not a big deal. You can figure it out, and you can even pick up a couple more points to graph him. So the bottom line is you should have no problem graphing the asymptotes, okay, with a little bit more details. All right, I want to go to the next page. Okay, so actually what I want to do, rather than going over this, I'm going to go over this at the end. I want to look at this one first, and then I'm going to go over that question at the end. Okay, you'll see in a moment why. Okay, because I want you to answer the questions. So with that being the case, let's see what happens here. This is a simple case. You want to analyze the equation. Remember what we do. We divide both sides by what? 36. Why? Because we want the right side to be 1. We want the right side to be 1 class. Okay. That's why we do that. And so let's see what happens when we do that. Sounds good? And so obviously A is 2 and B is 3. And we can find C, you know, if we are interested in finding the focus. When they say analyze, they normally want the focus 1 and focus 2 as well. Okay. So it is centered at 0, 0. It opens sideways with vertices at -2, 0, and 2, 0. And C is plus minus square root of 13, comma 0. Now you can come up with the asymptotes. Okay, y is plus minus b over a times x. 3/2 x, and y equals -3/2 x. Those are easy lines to draw, or you can come up with the fundamental rectangle. Okay, Remember the vertices are at 2, 0 and negative 2, 0. I don't believe anybody should have any, difficult time graphing this. That shouldn't be a big deal. But remember, the idea is that when you come up with this rectangle, fundamental rectangle, when you connect the diagonals, and all those are easy to find, you can see your asymptotes. You should have no problem finding the asymptotes, class. Finding the asymptotes should not be a big deal. Okay. All right, now I want to go to that question. Before I do that, is there any question? Is everybody clear? All right, I want to go to that question and then we discuss the exam. All right, I'm assuming we are okay with this. So here's the last question now. Indicate the type of conic the equation represents. And class, you can do that by putting it in standard form. But I want you to see an easy way out by just glancing at it. See if you can figure this out. So if I want to answer this fairly fast by looking at it, this one is what and why? Can anybody tell me? Can anybody tell me what type of a conic we have here by looking at it? This is a question from intermediate algebra class.
Common factor?
I'm sorry, say it again?
Common factor?
No, you don't need to common factor even. Yeah, you can common factor, but what I'm saying, you can just look at it and by looking at it, you should be able to tell. Can you look at it and figure out which one? There are 4 conics. This is a circle. Why is that? Because they are quadratic with respect to x and y, and they have identical coefficients, x squared and y squared. Is everybody following this? Okay. What about part B? Can anybody tell me what type of a conic part B is just by looking at it? Anyone? It's a question that I ask intermediate algebra students. Why is that? The coefficient of both of them are quadratic. That means x and y. What about their coefficients? They are opposites. In this case, they are identical. Okay. But look at the sign. Both of them positive. This is positive. This is negative, right? So both are quadratic. But the signs are negative. Or opposite. What about part C? Anybody can tell me about part C? Houston, we got a problem. Go ahead.
Oh, I just said ellipse.
Good, good. Why is that? How do we know this is an ellipse? Okay. We again have quadratic, both of them, not just one. And these numbers have the same sign. Same sign, but they are not identical. Same sign, but they are not identical. So I want you to compare and see the difference. Part A, they are identical. Both of them are the same number 6. In this case, they have the same sign, but they are not the same. What happens to part D? Can anybody tell me about part D? What do we have?
Is that also a circle?
Aha, perfect.
Oh,
Because you got to bring this one together before you make a decision. Both
the
of
other
them,
side, yeah.
very good. Both of them are quadratic with respect to x and y, both variables, and they both have identical coefficients. Okay? All right. What about E? Can anybody tell me what's going on with E? E and F are both what?
A parabola?
Very good. Why is that?
Because only one has a quadratic, it's squared. No.
Go ahead, you were saying.
So yeah, like 10x squared. So the x will I mean, I kind of have the concept, but I don't know how to explain it.
Good, good, good. Yeah. Only one of them is quadratic, not both.
Yes.
Okay.
That.
Now, here's the thing. With respect to part E, I hope you see that it opens up. Why is that? Because it is quadratic with respect to x. And then if you solve for y, okay, this is 10 over 5, which is still positive. Whereas this one, this opens to the right. Part F opens to the right. This one opens up. But both of them are parabolas because only one of them is quadratic. And that's it.